Today's lesson is called the Zero Product Property Day 1. We're going to start with the opening exercise. It says, consider the equation A times B times C times D equals 0. What values of A, B, C, and D would make the equation true? I'd like you to try this question on your own. Please pause the video, and when you're ready to go over the answers, you can resume. Okay, now that you've had time to try the opening exercise, the answer should be any set of values as long as A, B, C, or D equals 0. So when you're multiplying, as soon as you multiply by 0, you get 0. So as long as one of those variables, A through D, is a 0, then the whole equation will be equal to 0. Now, having done the opening exercise, I want you to try exercises 1 through 4. It says, find values of C and D that satisfy each of the following equations. There may be more than one correct answer. So again, I would like you to pause the video and try exercises 1 through 4, and then you can resume the video to go over the answers with me. Okay, now that you've had a chance to try exercises 1 through 4 on your own, let's go over the answers. For number 1, CD equals 0. C or D must equal 0 to be true. When you multiply by 0, you get 0. In number 2, you have to do C minus 5 times D equals 2. So you're looking for combinations of C's and D's that will work. So for example, if C was 6, D would then have to be 2 in order for the equation to equal 2. If C was 4, so 4 take away 5 would be -1, D would have to be -2 in order to make the equation true. So you can keep doing this pattern and actually find an infinite number of solutions. For number 3, C minus 5 times D equals 0 changes it up. If this is going to be equal to 0, then C is either equal to 5, so that 5 take away 5 would be 0, or D has to be equal to 0. You do not have to have both to be true. So it changes between 2 and 3 because what we equal was 0 instead of 2. And then in number 4, C minus 5 times D plus 3 equals 0. Remember the whole idea that when you're multiplying, as long as one of the values is 0, when you multiply by 0, you get 0. So either C minus 5 has to be 0, which means C would have to be a 5, or D plus 3 would have to be 0, which means D is a -3. So that's really how you should be thinking of all of these. When you're multiplying, one of those factors that you're multiplying by has to be a 0. So you're thinking about the situation that would make each piece equal to 0. So now we're going to move on and do example 1 together. For each of the related questions below, use what you know about the zero product property to find the answers. So A says the area of a rectangle can be represented by the expression x squared plus 2x minus 3. Write each dimension of this rectangle as a binomial and then write the area in terms of the product of the two binomials. So they want us to take x squared plus 2x minus 3 and write it as a product of two binomials. So in other words, they want us to factor. So this is a factor question to start. So we have to factor this. So since it's a trinomial, we know it's going to factor into two binomials. I need the factor pairs of -3 that are going to add up to 2. So that would be +3 times -1. So I'll do x plus 3 and x minus 1. So that's it written as two binomials. So now we just have to determine the dimensions, which is basically what these are. So your longer side is going to be the x plus 3. And your shorter side is going to be the x minus 1. So now in B, can we draw and label a diagram that represents the rectangle's area? So yes, this goes back to when we were multiplying polynomials, specifically two binomials. We used boxes to show our multiplication. So we're going to draw our boxes. And we see that we have x plus 3, and I can put that at the top or the side, it doesn't matter, and x minus 1 on the side. So x times x would be x squared. X times 3 would be +3x. -1 times x would be -1x. And -1 times 3 would be -3. And so this is a diagram that's drawn and labeled that would represent the rectangle's area. Now in question C, it says, suppose the rectangle's area is known to be 21 square units. So we actually know that the area is 21 square units. Can you find the dimensions in terms of x? So now let's think about area. We already showed the area up here as x squared plus 2x minus 3. It said right in the problem that that's how the area of the rectangle was represented. So we're going to take x squared plus 2x minus 3, and we are going to set it equal to 21. That's coming from the fact that we had area equals length times width. Our area is 21, and we know from up above that our length is x plus 3, and our width is x minus 1. And if we actually multiply those, we get that. So in D, rewrite the equation so that it is equal to 0 and solve it. So we're going to take our equation, x squared plus 2x minus 3 equals 21. And of course, instead of that order, you could have 21 equals x squared plus 2x minus 3. It doesn't matter. And we need to make sure that this is set equal to 0 so that we can factor and solve. So we have to move the 21 to the other side by subtracting it. So we get x squared plus 2x minus 24 equals 0. Now we can take that trinomial and factor it and set it equal to 0, because now we know from our investigations earlier that as long as one of the factors is equal to 0, the whole entire thing will be equal to 0. So I need the factor pairs of negative 24 that are going to add up to 2. That happens to be negative 4 and positive 6. So x minus 4 and x plus 6. Now again, using what we learned, I'm going to split this with what's called t time. I'm going to take x minus 4 and set it equal to 0, because if that part is 0, the whole thing would be 0. And then I'm going to take x plus 6 and set it equal to 0, because if that part's 0, the whole thing is 0. So now we solve each piece separately. I'm going to add 4. So x equals 4. I'm going to subtract 6. So x equals negative 6. Now this is a problem about dimensions of a rectangle. So immediately we are going to cross out x equals negative 6. And we're going to write over here that we are rejecting. So we'll reject as a value of x. And we're going to say side length cannot be negative. So in this context of the problem, the negative doesn't make sense. Okay. So now in question E, what are the actual dimensions of the rectangle? Okay, so remember that the longer side was x plus 3. But now that we know we're going to use x equals 4, so that's 4 plus 3, which means it's 7 units. And that makes my shorter side, which was equal to x minus 1, 4 minus 1, and therefore 3 units. Now you can do a quick check of that. If those are my dimensions, the area is equal to length times width, so I would have 7 times 3 equals my area, which means my area is 21, and they did say up above in part C that the area was 21. So we have done it correctly. Okay, now in example 2, I just want to show you a straightforward example of solving using the zero product property, no word problem involved. So it says x squared minus 11x plus 24 equals 0. Make sure that this expression is equal to 0. Ours is already. So you just want to make sure it's equal to 0 before you can factor. Since ours is, we're going to jump right into factoring the expression. So we need the factor pairs of 24 that are going to add up to negative 11. That would be negative 3 and negative 8. So we have x minus 3 and x minus 8. We are then going to t time. We're going to split it up into the two factors. So we have x minus 3 equal to 0. If that part is 0, the whole entire thing is 0. And then we have x minus 8 equals 0. Again, if that's 0, the whole entire thing is 0. So we can solve each of these pieces. Here we will add 3 and get x equals 3. Here we would add 8 and get x equals 8. So that means I believe the solution to be 3 and 8. Now to verify my solution, remember that just means that we're going to do a check. Now when we're checking, we have two solutions we have to check. So we're going to have to check 3 and 8. So I'll write the equation once at the center. And on this side I will check x equals 3, and on this side I will check x equals 8. When you are substituting, remember the importance of your parentheses. It can change values if you forget to use them. 3 squared in parentheses is 9. Then we would have minus 33 and plus 24 equals 0. 9 take away 33 would be negative 24 plus 24 equals 0. And therefore 0 equals 0. When we do the same thing with 8, remember again to put your parentheses around everything as you substitute in. 8 squared is 64. And we have minus 88 here with this multiplication. 64 take away 88 is negative 24. And then negative 24 plus 24 is 0. So it all checks out, and now we know for sure that the solution is 3, 8. So in summary, remember your zero product property. If A times B is 0, then that means either A is 0 or B is 0, or A and B are 0. So you're using that property in order to solve these types of equations. You want to factor them, set each factor equal to 0, and solve that part to find your overall solution. And that concludes your lesson on the zero product property, day 1.